Hello everyone, this is DSA Siddhamad. Today we are going to solve the 14th question of Arsh DSA sheet, and the question is awesome. Let's look at the problem statement. Given an array nums of n integer, return an array of all the unique quadruplets nums A, nums B, nums C, nums D such that 0 less than equal to A, B, C, D less than equal to n. A, B, C, D are distinct elements, and nums of A plus nums of B plus nums of C plus nums of D equal target. You may return the answer in any order, right? So, what is our main target? Our main target is to find out four quads A, B, C plus D such that their sum will be equal to target, right? This is our main goal. We need to find out four numbers such that their sum will be equal to target. Now, just look at the example. Example is 1, 0, minus 1, 0, minus 2, 2, and here our target will be equal to 0. So we need to find out four numbers such that their sum will be equal to 0. This is our goal, right? So from the given array, which is nums, right? So from this, we can find out we can take this element 1, minus 1, 0, and 0. This can be the initial pair, which is minus 1, 0, 0, and 1. And in the question, it is also mentioned you may return the answer in any order. So we don't need to consider about the order, right? So after this, the pair can be minus 2, 2, 0, 0, right? So second pair would be minus 2, 0, 0, and 2, right? Now third pair can be equal to 2, minus 2, minus 1, and 1, right? So the third pair would be minus 2, minus 1, 1, and 2. So we found out there are a total of three quads whose sum will be equal to the target value. So this will be our answer for this example, right? So now let's look at the second example also. So we are provided with the same element in the whole array, which is 2 over there. So we need to find out the target to be 8. So we'll just consider 2 plus 2 plus 2 plus 2. We'll try to add all the elements, and we found out that there is only one quad whose sum will be equal to the given target value, which is 8 over there. I hope all of you get what we need to do in this problem. We need to find out four numbers such that their sum will be equal to the target value, right? So now let's jump into the approach and try to figure out how we can solve this question, right? So now let's talk about the approach. So initially we are given this element. Let's take this example, which is 1, 0, minus 1, 0, minus 2, and 2, right? This is our num array. So now, and whenever, so first of all, let's talk about the brute force approach. Brute force approach. When we talk about the brute force approach, what comes in our mind? We just need to traverse over the array following some condition, following some conditions, right? We don't need to think about how many times we need to traverse over the array because initially we are trying to figure out what is the brute force approach for solving this question, right? So we need to find out four elements such that their sum will be equal to target value, and over there target is equal to 0, right? So initially what we'll be doing, we'll have four pointers for traversing over the array, right? Because for traversing over the array, we need some pointers, right? So let's say I is pointing to this, and J is pointing to this, and K is pointing to this. And uh, first of all, we'll try to fix the first three pointers, and just calculate the sum I plus J plus K. And we'll try to find out the fourth element such that their sum will be equal to the target value. This element can be found out from the remaining array, right? From this array, right? From this array, we can directly find out the L. Let's mark this element. as L, right? So initially we'll try to calculate the sum of all the elements, and after this, if we find out the target value, we'll just store this in some data structure, and this data structure can be considered as a hash set because we need to find the unique quads, right? So we'll try to let's say its sum will be equal to the value which is 1 plus 0 plus minus 1, and from there we can see like we can take this element which is 0 over there. So from the initial start of the array, what we can find out, there is one pair which is 1 0 minus 1 and 0, such that their sum will be equal to the target value, right? So after this, what we are going to do, we'll just traverse over the remaining part of the array. So initially our pointer will be pointing to this. Again, L will point to this. So its sum will be equal to not equal to the target value. Now it will point to the last element. Now again, we'll fix the element, this to be I and this to be J and this to be K. So now our remaining part of the array would be something like this, and we try to find out the L point over there from the remaining part of the array, right? So in this way, we are going to traverse over the array 4 times, right? So now let's discuss the times and space complexity for the same. Since we need to traverse over the array 4 times, right? 4 times, so it will require big of n raised to the power 4 time complexity, which is quite huge, right? And space complexity would be big of n, because we are using hash set for storing the unique elements, right? So now let's try to reduce the time complexity because its time complexity is quite large. So we'll try to figure out how we can reduce the time complexity, right? So now let's talk about the optimized approach, right? Optimized approach. So let's take this example, which is 1 0 minus 1, 1 0 minus 1, and after this we have 0 minus 2, 2, 0 minus 2 and 2, right? This is our nums array. So whenever we have given an array question, what comes in our mind? First thing is like just traverse over the array following some condition. Now after this, there is second thing which comes up in my mind, like we'll try to sort the array. Sorting, then we'll traverse over the array following some conditions. This is the second thing which comes in my mind, right? And this approach is much similar to the approach as we did in threesome, and threesome approach is much similar to the twosome, right? So what we are going to do, we'll try to follow twosome approach, which is like, first of all, we'll try to sort the array, then we'll traverse over the array following some condition, and the condition are like, will initialize two pointer left and right, and left will be pointing to the left side of the array, which is let's say 0, and right side will be pointing to the right side of the array, which is n minus 1, right? So I'll also attach the link to the video to the twosome and the threesome problem also, so that you guys have a better understanding how we are going to use the approach of twosome in our question, right? So now let's try to discuss like how we are going to use the twosome optimized approach in our foursome problem, right? So after sorting, our array will look something like this, which will be minus 2, minus 1, 0, 0, 1, and 2, right? So we'll do a diagram on this example, right? So initially, we'll have two pointers, I and J, pointing to the initial start of the array. And from the remaining part of the array, we'll apply the twosome approach. Left pointer being pointing to the start of the remaining part of the array, and right pointer pointing to the end of the area, right? This is exactly same as that of the two sum problem, right? So now what we try to calculate, we'll try to calculate the sum, right? So initially -2 -1 plus 0 plus 2. This will be equal to -1 since this value is less than the target value. So we'll try to increment the value of left pointer whenever we when ever we find out the sum to be less than that of the target value, then we'll increment left pointer. Otherwise, we'll decrement our right pointer, right? So we'll increment our left pointer. Now our left pointer will be pointing to the 0 again, but there is no need for the left pointer to pointing to 0 again because we already covered 0 part. So we'll try to avoid the duplicates. So instead of like pointing to the 0 again, we'll directly point it to the 1. So again, we'll try to calculate the sum, which will be equal to -2 -1 plus 1 plus 2. So now its sum will be equal to 0, which is equal to our target value. So initially what we have some sort of like vector or array in which we'll store our quads. So initially we find out the set -2 -1 and 1 and 2, right? So as we can see, like after this, both the pointers left and right crosses each other. So now we'll try to increment our j value by fixing the initial value of the I, right? So now our j pointer will be pointing to this, and our left pointer will be pointing to this, and right pointer being pointing to the right end of the array, right? So we'll check the sum again: -2 plus 0 plus 0 plus 2. This is again equal to 0. So we'll directly add this thing also to our answer, which will be equal to -2, 0, 0, and 2, right? We'll again try to calculate the sum, and now both the pointers crosses each other whenever there is this value, like whenever we find out that left our sum is equal to target, then we'll increment our left pointer as well as decrement our right pointer. So both of the pointers will be pointing to the one over there, so they both crosses each other. So we again increment our j pointer. Since j is already pointing to 0, so we'll avoid this 0. So our j pointer will be pointing to this. J is pointing to this. So there is no need, like since left and right will be pointing to the same element. So after this, what we'll do, we'll increment our I value. Now our I pointer will be pointing to this element. Let me just make this thing clear. Uh, so that you guys can have a better understanding, right? So now our I pointer will be pointing to this and j pointer will be pointing to this. And we'll try to calculate the left and the right from the remaining part of the array. So we'll again try to calculate the sum: -1 plus 0 plus 0 plus 2. So its value will be equal to 1, which is greater than that of the target. And whenever we find out this condition, then we'll try to decrement our right pointer. So our right pointer will be pointing to 1. Now we'll again calculate the sum: -1 plus 0 plus 0 plus 1. Its value will be equal to target value, which is 0 over there. So we'll again push this to our main answer, which will be equal to -1, 0, 0, and 1. So by avoiding all the duplicates, we are using constant access fields, right? Because in this case, we are not using any hash set or any other sort of like data structure to store all the elements. We are just avoiding the all the duplicates element in the traversing of the array, right? So after this, uh, like j pointer will be pointing to the 0 again, but there is no need since we already traverse 0. So after this, our j pointer will be pointing to the 1, but there is so after this, our j pointer will be pointing to 1, right? But there is no need, like since left and right both pointing to the 2 again, So both of the pointer crosses each other, so there is no need. So we'll again increment our I pointer. So now it will look something like this. Now our I pointer will be pointing to this and j being to this, and left and right. So 0 plus 0 plus 1 plus 2. This will be equal to 3, greater than that of the target. So we'll try to decrement our, but this condition arises, so there is no, right? So in this way, we find out like there are three quads whose sum will be equal to the target value, right? I hope this approach is clear to all of you guys. I'll also attach the same link for two sum problem and three sum problem so that you guys have a better understanding like how the approach of two sum is used there in our problem, right? So just try to watch the two sum problem before you started to watch this problem, right? I'll attach the link for the same in the description below. You can watch it over there, right? So now let's just try to code this thing up. So here we are. So int 10 will be equal to the size of the array, right? Now we'll declare a vector, 2D vector. Now after this, first step is to sort the array, right? Nums dot begin, nums dot end. Now after this, we'll try to calculate all the quads. Int I equal to 0, I less than n, I plus plus. Then now uh, we try to avoid all the duplicates initially, which will be if I is greater than 0 and then nums of I is equal to nums of I minus 1. Like nums of like current element is equal to the previous element. Then we just need to continue. We need to skip this element, right? Now we'll try to run the second loop, j from I plus 1, right? And j also less than n and j plus plus. Now again, we'll try to avoid the duplicates for the j also. Same thing, j greater than greater than I plus 1 this time, and nums of j equal nums of j minus 1. These both loops are for avoiding the duplicates element so that we don't need to use any other data structure, right? Now we'll initialize two pointers. Let's say k equal to j plus 1. This is the left pointer, and this will be equal to L will be equal to n minus 1. This will be equal to the right pointer, right? Now, while k, both the pointer crosses each other, we'll run the loop. Now we'll try to calculate the sum, long sum. We take this sum as long because it might come like it may go out of bound. So we'll try to take this as long instead of like int, right? Nums of I, then sum plus equal to nums of I, sorry, nums of j over there, nums of j sum plus equal to nums of k, then sum plus equal to nums of L also, right? Now we'll calculate if sum is equal to the target value. If this condition holds true, then we need to have a vector temp in which we are going to store all the quads, nums of I, nums of j, nums of k, and nums of L, right? And in the answer, we'll directly push this vector, which is temp, right? Now, whenever there is this condition, we need to increment our left pointer and we need to decrement our right pointer, right? And we also need to skip the duplicates, skip the duplicates, right? So for this condition, we have while k less than L and then nums of k is equal to nums of k minus 1, then we need to increment our left pointer. Also, same thing for right pointer, nums of L equal nums of L minus 1. Then we need to decrement our right pointer. If this is not the condition, else if sum is less than that of the target value, then we need to increment the left pointer, otherwise decrement the right pointer. Right. Now at the end of this, we'll directly return our answer. Now let's try to run this code. This runs perfectly fine. Now let's try to submit this code. So this will be equal to L plus 1 over there. There is some type over there, right? Because in the case of like right pointer will be shifting our element from the right side of the array. So we need to check for the L plus 1 instead of L minus 1, right? So again, we'll try to submit this thing. Yeah, this runs perfectly fine. So we also need to check our code once again at the end, like when we find that we'll finish the coding, because it's a good practice to just review your code when you finish your writing the code, right? So it's a good practice. So now let's try to discuss the space and time complexity for this problem. So here we are. Since we are sorting the elements, it will require big of n log n as we traverse over the array 3 times. First this for loop, second this for loop, and third is for this loop. First, second, third. So it will require big of n cube. So ultimately our time complexity will be something like this: big of n log n plus big of n cube. So ultimately this will be equal to big of n cube, right? And the space complexity will be equal to big of 1, right? Because we are not using any extra space over there. No extra space, right? I hope this approach is clear to all of you guys. Thank you so much for viewing the video till the end. Please like, share, subscribe, and comment if you have any doubt. Thank you so much.